right, I want to talk a little bit more about this idea of homeostasis that we saw in the last topic about the characteristics of living things. I mentioned at the end that homeostasis, even though it directly translated means that it stays the same, in reality, these things don't stay the same. We are constantly having to work to keep them within a normal range. So, let's talk about how that happens. All living organisms use something called negative feedback to maintain homeostasis. Negative feedback means that when you have a set point or a value where something should be, like your body temperature at 98.6 degrees Fahrenheit, right? This is where we set the thermostat. But our external environment is constantly changing, right? Sometimes it gets too hot and our body temperature starts to go up. Sometimes it gets too cold and our body temperature starts to go down. Now, the response to the deviation, when we go away from the set point, the response is to say, that's the negative part. Let's go back to the set value. All right, so we're correcting something, and that's really where the negative comes from. We're switching the direction of the change or the disturbance. So, in this example, when our body temperature becomes higher than the set point and reaches some certain level that kicks the system on, we start to sweat. And by sweating, that allows us the water to evaporate and our body temperature comes back down. Maybe we also even use our behavior, like, going inside to where there's air conditioning. But either way, we get our body temperature back down to this set point. But it doesn't just stop there, because now you're in the house with the air conditioning and it's, super cold. Or you're just in a shady environment, but your clothes are wet because you just were sweating. So now your body temperature goes below the set point. And the negative feedback response or the corrective response is to shiver. And when you shiver, your muscles are contracting really fast. And when your muscles contract, they produce heat, and that heat brings your body temperature back up. So that's a classic example of negative feedback maintaining homeostasis. And there are a gazillion examples of things that are maintained by negative feedback in our bodies, as you'll see as you go through the course. So negative feedback is anything that returns a factor back to its set point. Remember, it doesn't just put on the brakes and stay there. It goes right past it, and we have to correct it the other direction. Now, every negative feedback loop has three parts to it. There's a sensor or a receptor, something that can measure whatever factor it is that we're trying to maintain. There's a control center that can compare the actual setting to the setting that it's supposed to be. And then there's an effector or multiple effectors that if there's a difference between where something is and where it's supposed to be, the effector is the thing that does the work to bring us back towards the set point. In that example that we just looked at with body temperature, the sensor or the receptor is actually in the brain in a structure called the hypothalamus. The hypothalamus also plays the role of control center. So it's like, oh, wait a minute, we're at 99 degrees and we're supposed to be at 98.6. There's a difference. And then it sends a signal to whichever part of your body has to respond. In this case, it would be the sweat glands. So the hypothalamus is like, hey, sweat glands, make some sweat. Let's get the body temperature back down. All right, so those are the different parts that you'll see in a negative feedback loop. So I want you to think of negative feedback as like scolding a dog or scolding a kid. It is like you're breaking a rule, you're moving away from the set point, and the scolding, the negative feedback, is how we discourage that behavior from continuing. We bring it back to where we want it. Now, when homeostasis fails, disease results. We're going to talk about this example at the very end of the semester, but these are individuals that have goiters, which are enlarged thyroid glands, and it can come from a number of different things, but the most common is just a lack of iodine in the diet. And so when the thyroid gland can't make the right level of thyroid hormone, we can't make it because there's not enough iodine, then we cannot keep it at its set point. Homeostasis has failed. Negative feedback's not working here. Now, something that's worth mentioning is that we are all different, and so are our set points. So, for instance, when you get a blood lab back from after a doctor's visit, you will see that it will give you your value for something and a standard range. Now, the reason that it's a range, one, is that things fluctuate, even for every factor for every individual, but also our set points, whatever our control center is is trying to maintain it at, those are different too. So some people have a slightly lower body temperature on average, and some people slightly higher. Some people have a slightly lower metabolic rate, some slightly higher. So these things vary within the population, and therefore we always present things as ranges. It's not just our physiology, by the way, it's also our anatomy. So most individuals are born with two separate kidneys like this that have migrated up to where they end up in the abdominal cavity. Sometimes they're in different positions. Sometimes they are fused. Right? Same thing here. I don't know if this is large enough for you to see, but most of us have vessels coming off of the aorta out of the heart that branch in this pattern. But some individuals branch in this pattern and some in this one. So when you look at pictures of anatomy in your textbook or online and it shows what things are supposed to look like, just remember that there's an enormous amount of variation, and that's normal. Now, I need to talk a little bit about positive feedback because these things are all each about controlling something, but negative feedback, remember, is about keeping something steady or stable. Positive feedback is what we use in the body when we need rapid change. Now, the example that we're looking at here is a woman who is like way pregnant and the baby's ready to come out. So what's happening, if my hands are her cervix, is that the baby's head is pushing on the cervix, right? Because it's big and it's got nowhere else to go. Now, the cervix has sensory nerve endings in it, and when it gets pushed on or stretched, it sends a signal to your brain, to the pituitary, and it says, hey, we're getting stretched. And the pituitary says, I know what I can do about that. And it sends a hormone into the bloodstream called oxytocin. Oxytocin arrives at the uterus, and it causes the uterus to contract, which pushes the baby's head against the cervix even harder, which causes more signals to the pituitary, which makes more oxytocin, which makes the uterus contract more. Do you see how this is building in one direction, not returning? If this were negative feedback, then the baby's head on the cervix would send a signal to the pituitary, and the pituitary would be like, how can we get that to stop? I know, let's stretch the uterus even more, which mom's not going to like, just so you know. All right, so this is whatever change there is, we build on it. It's sometimes referred to as a vicious cycle or the snowball effect when we see it in non-physiological settings. So we are using positive feedback to encourage a behavior. You see your kid or your dog do something that's good, that's when you give them the treat because you want that behavior to continue going in that direction, maybe even get better. So, in summary, negative feedback is not bad. So, it's negative means to return to the set point, does not mean that it's a bad thing. And positive feedback is not always good. I'll give you some examples. We talked about body temperature, negative feedback. We also use negative feedback to maintain blood pH or potassium levels or glucose levels. We use negative feedback to control hormone levels, even to control how they cycle in like the menstrual cycle. Now, places where we see positive feedback, labor, which we just talked about, blood clotting. We need that to happen fast so that you don't lose all the blood before we finally finish doing the job. But we also see it in something called circulatory shock, which is where, to give you an example, if you've lost a lot of blood, then the heart's not pumping as much blood. It's just not there. If the heart's not pumping as much blood, then it's not able to feed itself enough blood and oxygen. And if it doesn't get enough blood and oxygen, then it gets weaker and it pumps less blood. And the less blood it pumps, the less blood it gets, the weaker it gets, the less blood it pumps. See how we're just building in that same direction? That's positive feedback, but it's not good. All right. See you next time.